Hi, student. This is Dr. Saud Malik here. Once again, I'm coming here with an interesting topic that is about the distance between 2 points on a coordinate plane using Pythagoras theorem. That particular point we are discussing over here, and before knowing about it and before working with it, first of all, we need some prior information about two things. The first thing is that what is the coordinate plane? If you are not aware of this concept, surely that will give you a kind of problem in understanding. And the second thing which we need about understanding this thing that is known as the Pythagoras theorem. So all these two things, first of all, we will clear over here. And the coordinate plane is quite simple. Let's take it. For example, this is the plane which you can see over here. And here, if I am creating a kind of axis which you called x-axis, and this x-axis over here, and the other axis I'm creating over here, for example, that is the y-axis. Give me times for that. This is the y-axis. If I can see that that whole plane is divided into four portions over here, they are known as the quadrant. That one is the first quadrant, okay? That is called first quadrant. And this one is the second quadrant. And the other one is the third. And this one is the fourth quadrant. These quadrant and these quadrant are specifically assigned for the values of the x and y points as the positive and negative. So whatever is present on the right of this particular origin, that is known as the origin, right? So whatever is present on the right side of that origin is positive, and whatever is on the left, that is negative. Similarly, on top of that origin is the positive, and the below to that is the negative. So any point if located here, for example, if I'm putting a point over here, that is the point A, and if I want to know where is it located, so I need to find out two things about it. First of all, I'll take how far is that from the x-axis. Can you see that? This is the first point, this is the second mark, this is the third mark. So it is on the third of the x, which I can represent like that. And similarly, I can see that on the y-axis, it is 1 and 2. That is on the second point of the y-axis. I mean, the second value of the y-axis. So this thing we can represent over here as the x value. The first we will took the x value, that is 3, and the y value, which is 2. So altogether we can say it is A, which is in the coordinates is at 3 and 2. So that 3 value is representing its value on the x-axis, and 2 is representing it is on the y-axis. All right. So each and every point in this way we can use as the x and y locations. They are known as abscissa and ordinates. X is known as the abscissa and y is known as the ordinate. So that is called the coordinate plane. Now the second thing we should know about that, that is the Pythagoras theorem. So what is the Pythagoras theorem? First of all, I would like to give you a brief idea about it. That theorem is basically designed for the right angle triangle. If you can see that, this is a right angle triangle I'm drawing over here. And this is the diagonal line, which is known as the hypotenuse of that. For example, this is X, Y, and Z. These are the 3 points of the triangle, and this particular angle is of the 90 degree, that is the right angle. So this particular line, which is looking like the erect line, that is known as the perpendicular. Okay, perpendicular, right? Or you can say that height. Both words you can apply over here. And if you will see that other line, that is YZ, that is known as the base. It is called base. You can call it base. And this third line is the diagonal one, which is the longest one in them, that is known as the hypotenuse. All right. So this particular uh, theorem is about to get the relation between them. That hypotenuse square, whatever is the value of the hypotenuse square is equals to base square plus perpendicular square. Okay, so that is the way we can find out any one of them. So let's go through how we can find out the value after knowing these two things we can apply over here. Suppose I'm giving you 2 points at a different location and a line is between them, for example. Okay, so I would like to draw that again over here. Suppose that is the line, and we need to find out the value of this distance. This is the point A, and this is the point B. So, what we need to do? Very simple. First of all, we will create a coordinate system over here to find out. That will create an ease in this calculation. And I am creating that over here. Look at this. Hope you are getting this as explained on the previous screen. This is point A, this is point B. So that is the x-axis and the values are marked over here. This is the 1, that one is the 2, this point is the third, that is fourth, this is 5, 6, 7, 8, 9, 10, 11, and 12. And the same thing we can do over here. We can do some graduation, some marking over there. That will give us the value. That is the 1, that is the 2, 3, 4, and so on. So this point is known as the origin, as you know that for the x and y, for both things, it has value of 0 each. So let's find out the coordinates of A first of all. If you can see that coordinate, the x coordinate I can get by putting a perpendicular on the x-axis. That is the value. I can say that A point has the value of x as 2 and the value of y as the point 1. Right? So these are the coordinates of the point A. Now let's find out these coordinate for the B point. As you can see that this is x value is 11. So I'll take that 11 and the y value is coming as 4. So I'll take 4. So these are the coordinates of the B point. So I can say that this is also having x, so I can use that x1 for it. And the y I can mark as the y1. And same thing I can do over here. That I can say as x2 just to differentiate them. And this is the y2. All right. Now let's apply the Pythagoras theorem. But very simple that theorem shouldn't be visible here until unless you will not create a right angle triangle. So how can you do that? Just extend this line like that, okay? And just draw a perpendicular from here to there. Now look at this. This is the right angle triangle. So that right angle triangle is going to be helpful for you. But first of all, you need to find out the value of the base. As you can see that base is from 2 to 11. So I need to find out that value, how much that is going to be. Obviously, you can put a value over here. You can find out that by x2 minus x1. So finally, that answer will come as 11 minus 2. So that is going to be 9. So this is the value over here. Same thing we can apply over here. This is from 3 to 1. Can you see that? This is 3 to 1, right? So I can do that by taking difference of the y2 and the y1. It will be 3 minus 1 and it is 2. Now we can apply over here. So as we can see here, AB is the distance. So according to the Pythagoras theorem, AB square is equals to AC square plus BC square. All right. Now I'll keep the value over here. So AB square is equals to that AC square thing I can find out by x2 minus x1, and that BC square I can find out by that y2 minus y1 whole square of both of them. If I want to find out AB, so I need to change that square. I'll take it on the other side, so it will come as a whole root over here. You can see that that is the whole square root on the x2 minus x1 whole square plus y2 minus y1 whole square. All right. Now simple thing, we will apply the value over here. So I'll take that whole root, and x2 minus x1 is already solved over here. That is 9. 9 square plus 2 square. So finally the answer will come as 81 plus 4, means that is going to be 85 root. So that is the way to find out. We can calculate that value of the root by the any method like prime factorization or the long division method. So in this way we can find out that answer. Hope everything is clear to you. So have a great day. Thank you so much.